Hey guys, Mr. Santiago here. I hope you had a wonderful weekend and I'm glad you are here watching this lesson today. Can't wait to see your flip grids that you've been putting together and also to see you guys in Zoom. Don't forget to make sure you join in Zoom so you can get a quick review and of course also ask any questions that you might have regarding the topics that we're talking on. Today we're going to be moving into gravity. So we're going to be learning more about the force called gravity, and we're going to add that on to the previous forces that we've learned about, like pushes and pulls and friction. So make sure you watch the video, get your notebooks out, get ready to take some good notes. This is the introduction again of a new concept. So we'll be learning about gravity, we'll watch a video, we'll do a quick slide or two, a little bit of highlighting in our speed bag, and then we'll be all set. Once again, hope to see you guys in Zoom and have a great day. All right, let's get our notebooks ready. Don't forget you can always pause the video at any time to take some notes and to write any important details down. Hope you enjoy it.
Ow! Well, you didn't have to drop it on me. Dear Tim and Moby, how do we stick to Earth? Why don't we just fly off into space? From Chrissy. Sometimes I wish Moby would fly off into space. Yeah, whatever. Now, let's talk gravity. When Moby let go of that apple, it dropped towards Earth and hit me along the way. For thousands of years, philosophers wondered why this was so. Did Earth have some special quality that attracts all objects? It took a certified genius named Isaac Newton to figure out the answer. He reasoned that there was nothing uniquely attractive about our planet. Instead, a force called gravity made all objects behave this way. Everything in the universe has gravity. Earth, the sun, the moon, apples, even you. Newton proved that you could calculate gravity's pull with just two things, mass and distance. Massive objects exert a stronger pull than less massive objects. And objects that are far apart exert less gravitational pull on each other than objects that are closer together. This thinking satisfied scientists for more than 200 years. But then Albert Einstein came along and expanded on Newton's ideas. Good going, Einstein. Einstein wondered how gravity really works and why it depends on mass and distance. In his general theory of relativity, he showed that mass actually bends space. The more massive an object is, the more it bends space, and the greater its gravity. Yeah, it's hard to picture how space can bend, probably even for a brainiac like Einstein. New scientific theories often raise more questions than they answer, but you can think of it like this. If you put something massive on a trampoline, like a bowling ball, the surface sinks in a little. Put a smaller object nearby, like a marble, and it rolls toward the bowling ball. Kind of like how Earth orbits the sun. Well, it's not a perfect analogy. But don't worry, in real life we won't fall into the sun. Back to our question, Earth's gravitational field pulls you toward the center of the planet. Since all objects possess a gravitational field, you're actually pulling back on Earth. But your pull is so much weaker, it doesn't make much difference. An object's mass isn't the same thing as its weight. Mass has to do with the amount of stuff in an object. And weight is the force exerted on an object's mass by gravity. On the moon, an apple weighs 1/6 as much as it does here. It's the same apple, but the moon's surface gravity is weaker because the moon is only 1/6 the size of Earth. Weaker surface gravity means that astronauts can jump 6 times as high on the moon as they can at home. The moon's gravity pulls at Earth, causing the ocean's tides. Earth's gravity keeps the moon orbiting around it. And the sun's gravity keeps us orbiting it. Gravity even holds planets and stars together. It's one of the most important forces in the universe, as far as we're concerned. Without it, we wouldn't even have a planet to stand on. Moby! Ah!
Keep in mind, if you'd like to do any of the additional activities like the games or the quizzes or anything like that, you can go to brainpop.com, just type in your password, which is pines.student at rexpines.org, and then the password is student1, just like the login used to be for the computers. You can click on the quiz, go in and challenge yourself just like we used to do in class. As always, Brain Pop videos are always a lot of fun, and of course, they're very informative. So there was a lot of information in that video about gravity, but you don't need to know all of those details, okay? There's only certain things that you do need to know, and we're going to talk about that right now. We're going to start beginning the introduction of gravity and kind of letting you know and getting focused down to the things that you do need to know. So again, make sure that you have your notebook out. Make sure that you are taking notes as you watch these videos. Okay, so, and again, I'm going to keep them very short. So the slides, just a few slides and just one paragraph on the speed bag, and then we'll be all set for today. All right, so here's our slide, forces that contribute to motion. We're going to talk about the next one. We've been talking about push and pull. We talked about friction, and now we're talking about the law of gravity. Okay, and here's a rendering of Sir Isaac Newton, as you saw in the video, with the apple in the tree, and the apple fell down, and that's what gave him the idea to start thinking about gravity. And here's our definition for gravity: the force that attracts a body towards the center of the earth or toward any other physical body having mass. So that word body, that literally means anything. In this case, we could say, okay, we could call ourselves, we have a body as humans. So we could say that our body attracts to the earth. That's why we're able to stand. But anything else as well, like a table or a pencil or a cup, right? All of these things, they are also, in this case, would be considered a body. Okay, and all of those things are being pulled toward the center of earth. So gravity is a pull force. Okay, and it's being pulled toward the center of Earth. So that means everything is always being pulled down toward the center of Earth, because Earth is a sphere. It's basically like circular shape. So if everything's being pulled to the center of Earth, that means it's being pulled down. Okay, so there's a few things you could do when you get your speed bag out. You could either have a highlighter, and you can highlight along with the things that I highlight, or you can also have your pencil out and you can underline. And then again, you could also take notes from the speed bag and notes from what I talk about when we read the speed bag. Okay, because if you're taking notes, then again, you don't really have to go into the speed bag to study. You could just go straight to your notes and you could see all of that information and the details right inside of your notes. Okay, so let's read along together. This is the fourth paragraph in our speed bag, page 127. The law of gravity is based upon the gravitational force acting between any two objects within the universe. The force that keeps us grounded is the force of Earth's gravitational pull. There is gravitational force between all objects on Earth. There is gravitational force between all of the objects in space. There is also gravitational force between objects on Earth and those in space. The more massive the object, the greater the gravitational pull towards the larger object. For example, instead of one person pulling towards another person that is more massive in size, people pull towards the more massive object that is Earth. Although the sun is more massive than the Earth, all matter on the land pulls towards the Earth because the force of gravity is stronger due to the closeness in distance. Therefore, we know mass and distance of an object affect the law of gravity. All right, so let's dig into this just a bit. All right, so let's highlight. So the law of gravity is based upon the gravitational force acting between any two objects within the universe. Okay, so that means literally any two things. The universe is huge. Remember, the universe is what everything is in. So any two objects in the universe, that could be you and me, that could be the mouse that's on the table and the pencil that's nearby it. Those are different objects, right? So any two objects. Okay, the force that keeps us grounded is the force of Earth's gravitational pull. Okay, so something to remember here, Earth's gravitational pull. That's what keeps us grounded. Okay, so the reason why we're able to stand on the Earth is because of Earth's gravitational pull. Remember, it doesn't say push. Earth's pull. Earth is always, gravity is always pulling. Okay, and then it's important to remember there is gravitational force between all objects on the Earth. Okay, there's also gravitational force between all objects in space. And there's also gravitational force between objects on Earth and those in space. Okay, the more massive the object, that means the bigger the object, the greater the gravitational pull, which is why we're all pulling to Earth, because Earth is much, 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 much bigger than us. So Earth is always pulling us towards it. Okay, and we have, even though we have gravitational pull, we don't have enough to do anything to Earth, right? So we are being pulled to Earth, and our gravity is not strong enough to go against that. So we're not pulling Earth to us. Earth is pulling us to it. Okay, and then they go on to give us that example. For example, instead of one person pulling towards another person that is bigger than them or more massive, as they say here, people pull towards the more massive object of Earth. So we don't pull to each other, we pull to Earth. Okay, and then even though the sun, this is important, this is something that's key, and I'll mark this by underlining it. Even though the sun is more massive than the Earth, right? So you would say, but the sun is much bigger than Earth, so why don't people pull to the sun? Well, that's because closeness in distance. Okay, that's because we are closer to Earth than we are to the sun. So because we are so much closer to Earth than we are to the sun, and Earth is still pretty big, we pull to Earth instead of pulling to the sun. So by understanding that, then we know that mass, right, how much matter is in an object, and distance, how far or close something is, affects the law of gravity. Okay, so we know that how much matter is in something, how heavy it is, let's say, or how far or close something is going to affect gravity. The further you are from something, the weaker the gravity pull is going to be, which is why we don't pull to the sun, because we're so far away. But we're so close to Earth that we pull right to Earth. Okay, Earth pulls us right to it. All right, guys, so that's it for today. Make sure that you do go on Edmodo, check your assignments, keep up with your assignments. I look forward to seeing you on Zoom. I look forward to seeing your flip grids and to being able to share them with you guys as well. Don't forget, those are mandatory. So if you're having any issues with figuring out how Flipgrid works, just message me, join in on the Zooms. I can help you a lot quicker that way. But if you have any kind of device, Zoom, Flipgrid is very easy to do. So make sure you're keeping up with those flip grids. And again, if you have questions, message me.